we have an amazing opportunity to reshape RAN.
And this is why we're so excited about working with Nokia on AI RAN.
We said we will do it with Nokia and NVIDIA.
In March 2026, we completed an AI for RAN proof of concept with Nokia in Finland.
The network that actually processes both at the same time, bits and tokens.
AI-powered RAN will be a key to enabling flying taxis.
As a result, we saw a nice increase in downlink spectral efficiency.
Now it is not proof of concept. We are talking about scaling this and creating real impact.
Imagine a RAN that evolves at software speed, not at silicon speed. A RAN that delivers twice the spectral efficiency from the spectrum that you already own. An open programmable RAN ready for the AI era. Now that's RAN reimagined, and that's Nokia's AI RAN. Now looking at the industry narrative around AI RAN, you will see that most vendors are discussing individual AI features, future cloud-based implementations, custom silicon evolution, and performance or efficiency gains that are in the range of 10 or maybe 20%. But we already live in a different reality. As AI becomes the dominant workload in mobile networks, it changes everything. At Nokia, we are building AI RAN to deliver the performance of AI without the price of AI. Because the reality is that the AI era won't wait, and the first movers get to define the next decade. Now, as a business leader and as a technologist, I am excited about Nokia's leading role in this fundamental transformation of RAN. In fact, we have designed Nokia's AI RAN to deliver what the AI era demands. First, we are providing twice the spectral efficiency with advanced AI algorithms running on AI-accelerated merchant silicon at radio timescales. Second, we are providing innovation at software speeds, new features, new AI models, security and resiliency upgrades, all delivered continuously through software. This is how RAN evolves from here. Our anyRAN software platform is common across all deployment options and ready for models that don't even exist yet. Now, the third point is that we are now bringing 3 deployment paths on one AI RAN platform. Same software, same roadmap, same 6G destination. You can build on your AirScale installed base, or you could go for a high-capacity distributed path, or you can choose a cloud-native path. It is your choice. The fourth is transformational economics. Our hardware pricing is in line with the prior generation baseband. This means twice the capacity for the same investment, or half the cost per delivered bit. A leap in TCO and power with no GPU premium. Now, the fifth is RAN becomes an open programmable platform. We provide full support for ORAN and any ORAN compliant radio. We offer a developer-ready platform. We expose data for real-time AI applications and support third-party DApps. And our AI RAN is ready for integrated sensing and physical AI. So let's take a closer look at all the 3 hardware tracks, which all run our common anyRAN software with a shared roadmap. First is the AirScale ABIG. You build on what you have. This is our AI-accelerated plug-in card for AirScale baseband. It's a next-generation capacity solution that perfectly fits into today's install base, providing the leanest migration path with investment protection. Second is our accelerated AI RAN node. This is AI-accelerated high-capacity solution suitable for any installed base, including AirScale, and for standalone deployments. It provides a highly scalable path all the way from 4G to 5G to 6G. Now, by the end of the year, we will disclose more details on this ultra-performance solution. And then third, our AI RAN COT servers for a cloud-native path. This is a cloud-native solution for AI-accelerated Cloud RAN. It builds on GPU-powered servers from leading vendors, including Dell, Supermicro, Quanta. Now, the Cloud AI RAN is multi-purpose by design, supporting both distributed and centralized deployments. It maximizes synergies with distributed inferencing and AI grid rollouts, where operators and hyperscalers share accelerated computing infrastructure across AI workloads and RAN. So now let's consider why all this matters to telecom providers. From a 2026 snapshot, we can see that networks are already delivering 100 trillion tokens per day, or 1.3 trillion AI interactions per year. And let me be clear, this is just the beginning. When I'm discussing these developments with operators, they confirm the same point. The industry needs a step change in spectral efficiency to create bandwidth for AI traffic within the finite spectrum. This is because in the AI era, high spectral efficiency means that you can serve a multitude of AI applications and agents. Or in other words, you can deliver more tokens over the network. And you can do all this while also providing a better network experience to more users. And for us at Nokia, this is not just theoretical. In fact, we have proven AI-assistant RAN algorithms across channel estimation, across link adaptation, across carrier aggregation. And just by doing this on our existing platforms, it has given us more than 20% proven spectral efficiency gains. But when you bring in more complex, more advanced AI algorithms on an accelerated compute platform, the gains just compound. We're talking about doubling spectral efficiency by 2028. And this is all based on the work that our teams at Bell Labs and our product teams have been doing in creating AI algorithms that are used with multi-user MIMO pairing, deep receivers, deep transmitters, deep schedulers, in advanced and non-linear channel estimation methods. Now, all of these need accelerated computing. And our roadmap of doubling RAN spectral efficiency by 2028 is built on a credible foundation. Our work is validated through structured proof of concept programs with leading operators, including T-Mobile US, SoftBank, and Indosat. And we are now running multiple validations in partnerships with customers across North America, Asia, and Europe. Now let me talk about the very clear vision we have at Nokia. RAN innovates at software speed. Future innovation should not be tied to slow hardware upgrade cycles. And to execute this vision, we decided to move from custom chips to AI-accelerated merchant silicon that meets the requirement of telecommunication networks. Now, why does this matter? Because when innovation moves at software speed, it changes the economics of RAN. Our customers can deploy new software features continuously. We can scale larger AI models faster. Spectral efficiency and performance improvement are no longer gated by hardware. Ultimately, the capabilities we build will enable the activation of AI-native RAN with software. Of course, software can further benefit from hardware upgrades that come in line with merchant silicon innovation. With the Blackwell GPU generation, NVIDIA has set an inflection point for GPUs in RAN. So let's hear from NVIDIA's Ronnie Vashishta about the Blackwell-powered NVIDIA Arc Pro platform.
AI RAN really needs one thing to break through: an accelerated computing platform that can run advanced algorithms in live networks at scale. That's exactly what NVIDIA Arc Pro for DRAN and the NVIDIA RTX Pro 6000 for CRAN can bring. Built on our Blackwell architecture, these off-the-shelf systems bring the full NVIDIA and Nokia innovation engines into the RAN with the performance and power efficiency telecom networks expect. Now, operators can step beyond fixed, single-purpose, legacy compute and run richer AI models for beamforming, interference management, and scheduling in real time. Together, NVIDIA and Nokia are shaping a new class of AI-native, software-defined RAN, more efficient, more adaptable, and ready for the continuous waves of innovation to come.
Through a pioneering collaboration with NVIDIA, AI RAN can now be deployed on AI-accelerated merchant silicon for the first time in the industry. Together with the ecosystem, we are creating the industry's leading platform for software-defined AI RAN architecture. In addition, our anyRAN software is open to benefit from the latest GPU progress and ecosystem innovation. In fact, we are working with an extended ecosystem of innovative companies on AI capabilities embedded in the RAN itself. And we are building all of this in the open with the AI RAN Alliance, with 3GPP, and with the standards-based processes that give telecom providers the confidence to invest at scale. I hope you are as excited as I am about what we have announced today: a groundbreaking AI RAN platform and 3 hardware evolution tracks that match the deployment realities of radio networks. With advanced AI algorithms, this platform delivers up to double the spectral efficiency in RAN. Nokia AI RAN is programmable and open, ready to support a multitude of AI applications. And we enable continuous upgrades delivered through software. This is the direction we have committed to. This is the direction we are inviting the ecosystem to build with us. And it is the direction that will define Nokia's role in the AI era as we lead the transition. From networks that carry traffic to AI-native networks that adapt and self-optimize with AI to extract more value for every hertz. From scaling capacity to scaling spectral efficiency at the speed of software innovation. And ultimately, from connecting people to connecting intelligence. This is the beginning of AI native RAN, and it starts now.
AI RAN is a platform decision that becomes valuable over time.
At the end of the day, technology is meaningless if it is not creating real impact for people.
Smarter scheduling and carrier aggregation will help us get more out of every hertz of our spectrum.
AI RAN empowers a software-driven platform that can deliver up to 40 to 50% more spectral efficiency in ideal conditions by the end of 2027.
For the next 2 to 3 years, we will lead the AI era with Nokia together.
With AI RAN, our ambition is clear: to double the spectral efficiency by 2028 and unlock the capacity that the AI era demands.